Welcome friends. In this new video we will discuss about homogeneous and non-homogeneous differential equations of the first order and first degree. The homogeneous equations of the first order and first degree can be put in the following form. The equation is like dy by dx equal to f1 of x comma y divided by f2 of x comma y. Here f1 of x comma y and f2 of x comma y, f1 f2 are homogeneous expressions, of the same degree in x and y, of the same degree in x and y. In this equation, to solve this equation, substitute y equal to v into x. Differentiating this, we get dy by dx equal to v plus x into dv by dx, so that this equation reduces to v plus x into dv by dx equal to function of v, where in the right side you can see that we have substituted y equal to vx, so that xx will be get cancelled and we remain the terms only with v, and easily we write this equation in the form x into dv by dx equal to f of v minus v. This gives dv divided by f of v minus v equal to dx divided by x. You can see that terms on the right sides contains only x variable and terms on the left sides contain only y variable. So here variables are separated and we can easily integrate these equations. So once again let us see what type of these equations are. Dy by dx equal to f1 of x comma y, f2 of x comma y, where f1 f2 are homogeneous of the same degree in x and y. Every term is of same degree in the numerator as well as in the denominator, and such type of differential equations are called as a homogeneous differential equation. When such type of equations encountered, we have to put here y equal to vx. Then you can easily see that to find the value of dy by dx, we get v plus x into dv by dx. Then these equations reduces to simple form, that is x into dv by dx equal to f of v minus v, where we can separate the variable containing x and y, and of easily integration we can solve this differential equation, and finally in the solution we have to put the values of v, that is y by x. Okay, so to get the clear idea, let us see example of this homogeneous equation. This is method of solving this differential equation. When we see the example, you can easily get the idea of these homogeneous equations. Let me Write first the equation x square plus y square into dx minus 2xy into dy equal to 0. In this equation, it is not in the form of dy by dx. Here you can easily see that it is like dx and dy are in the two terms, separated terms, where the multipliers of dx are x square plus y square. Now when we separate each term, you can see that degree of each term is a square degree, but here you can see that here x is 1 and y is 1 degree in the second term of this differential equation, 2 into xy. In a such a case, we have to add the degree of both these term x and y. Degree of x is 1 and degree of y is 1, and they are in multiplication, and therefore if they are in multiplication, we have to add their degrees. That is, we get the combined degree of this this term x and y. Degree of this is 1, degree of this is y, and these two are in multiplication. Therefore we have to add this degree of these two terms and we get square terms. So here degree of this term, combined term x and y is 2, degree of this term is 2, and also degree of x square is 2, degree of y square is 2, xy is 2. So everywhere we get degree 2, and there this means that this is a differential equation of degree 2, and hence it is a homogeneous equation. Now in this homogeneous equation, to solve this homogeneous equation, we have just seen that we have to put y equal to v into x, then dy equal to, apply the product rule, derivative of the first term dv, second term as it is, plus first term as it is, derivative of the second term, that is dx. Here we get the value of dy equal to x into dv plus v into dx. Let us put this value in this expression. You can see that x square plus y square means v square into x square into dx minus 2 into x into v into x into dy, x into dv plus v into dx equal to 0. Now friend, you can see that all the terms contain x square, x square, x square, x into x, x square. So common and cancel. Then this equation becomes 1 plus v square into dx minus 2v into x into dv plus v into dx equal to 0. Now we have here you can see that let us multiply by bracket to this bracket term by 2v, then 1 plus v square, 1 plus v square into dx minus 2xv into dv minus 2v square into dx equal to 0. Here dx and here dx. So this combined term, combining these two, we get, we can write this as 1 plus v square minus 2v square into dx common equal to 2x into v into dv. Now v square and minus 2v square, 1 minus v square into dx equal to 2x into v into dv, right. So let us transform this x to this side and 1 minus v square to this side. So easily you can see that we get here dx divided by x equal to 2v into dv divided by 1 minus v square. Again taking this term to this side, dx divided by x minus 2v into dv divided by 1 minus v square equal to 0. In the second term, you can see that the numerator is a derivative of denominator. Derivative of denominator minus 2v into dv. So numerator is a derivative of denominator, and hence if we integrate this equation, we get a term log. Therefore, on integrating this, we get log of x plus here this minus 2x square. So this minus we can write this here, and here it will be plus minus. This minus total term is a derivative of denominator, and therefore here we get plus log of 1 minus v square. Now we consider the constant term as a log of c. Log of x into 1 minus v square equal to log c. Now log get cancel, and we get x into 1 minus v square equal to c. Substituting the value of v, x into 1 minus y square divided by x square equal to c. Now reciprocal, if we take reciprocal, x into x square minus y square divided by x square equal to c. This square and x get cancelled, and we get x. Now let us transform to this side. So what this will be? This is equal to so new tab is open. So let me first clear this. Now you can see that here the solution of this is, I will write here the solution, x square minus y square equal to c into x. So this is a very simple relation between x and y. Also remember the procedure. What is the procedure? Look at the degree of each term. If degree of each term is the same, then that equation is a homogeneous equation. In such a type of homogeneous equation, put y equal to vx, and easily this equation is reducible to the method where we can separate the variables, and which is easily integrable. And easily integrable equation will gives us a relation between dependent variable and independent variable. Okay, so let us see one more example so that your idea will be clear of this homogeneous equation. This is a very simple, friend, do not bother about this. See the degree of each term. Whenever degree of each term is same, when it is of the first order. First order means whenever there is a terms like dy by dx, then see the degree of each term. Whenever the degree of each term is the same, then directly put y equal to vx. Again we have to calculate the value of dy by dx. So calculate the value of dy by dx and put that value, and when you do some simple calculations, the equation will be reduces to a very simple method of separation of variable, where we can separate the variables, and direct integration will gives us so relation between two variable, that is x and y, and that will be the solution of this differential equations. Okay friends, I hope your idea is clear. So let me see one more example. y square into dx plus xy plus x square into dy equal to 0. Okay friends, here again in this problem you can see that we do not have a direct term dy by dx, but easily this is we can obtain that term. no doubt, and see the coefficients of this dy by dx, that is dx and dy. Coefficient of dx is of second order degree y square. Okay, now see the coefficient of dy. You can see that the coefficient of dy contain two terms, one is a x square and other is a xy. Again, as we have seen in the previous example, we have to calculate the degree of this combined term x into y. Both are in a multiplication and therefore we have to add their degrees. So degree of x is 1, degree of y is 1, and addition of these two gives us addition of these x and y gives us 2. So each term is of degree 2 and therefore this is a homogeneous equation of first order. And in such a type of equation we have to simply put y equal to vx. So let me put y equal to v into x. Now friends, we have to calculate dy. Dy means derivative of y. Okay, so whenever we want to calculate derivative with respect to y, that is derivative of y here, but these are the two terms, then apply the product rule. Derivative first term into derivative of second, right? So first is v, derivative of second dx, plus derivative of the first term, second term as it is, second x as it is, derivative of y v is dv. Okay, so let us put this value y square means v square into x square into dx plus x into y. What is y? V into x plus x square into, now let us write here dy. What is dy? V into dx plus x into dv equal to 0. Now you can see that everywhere here x square, we can take x square common. Here is also x square. From all these terms we can take x square common. Okay, so I will write one more step. This is x square v square dx plus x square common, so we have v only plus 1 into v into dx plus x into dv equal to 0. Now from these two terms let us take x square common. Here is x square, here is x square, x is x square common and cancel, right? So we get v square into dx plus v plus 1 into v into dx plus x into dv equal to 0. So how we have obtained this? By taking x square common in the this previous term. Okay, now let us multiply this. We multiply first v square into dx plus v into 1 plus v into dx plus x into 1 plus v into dv equal to 0. So here we have you can see that x dx and dx. Now take dx common and v square plus v square into dx plus x into 1 plus v into dv equal to 0, right? Now we separate variables, that is divide by this term. When we divide we get here x plus x into 1 plus v divided by v plus, you can see that v square here, v square and v square 2v into dv equal to 0. Again dividing by x. If we divide by x, this x will get cancel and appear here. Okay, right? Now I write here dx divided by x plus 1 plus v into dv divided by v plus 2v square. Here v square is remain, I have written only v2. Okay, now let us see that what we need. We have if we take the derivative here, derivative of this term, what is the derivative of v square? With derivative of v plus 2v square equal to, you can see that 1 plus 4 into v. Now we have 1 but we do not have 4v. So we need 4v but we have only 1v. So we write this 1 plus v equal to 1 plus 4v minus 3v. Okay, or instead of doing this, this is one method how we can separate the numerator, and another method is partial fraction. If we write this denominator as a v into 1 plus 2v, let me write first, so that that will be very easy method. Dx divided by x plus 1 plus v into dv divided by, if we take v common, we get here 1 plus 2 into v equal to 0, equal to 0. Now friend, we write here 1 plus v divided by v into 1 plus 2v equal to a divided by v plus b divided by 1 plus 2v, and you can see that a into 1 plus 2v plus b into v divided by v into 1 plus 2v. Then equating the numerator on this both sides, we get 1 plus v equal to a into 1 plus 2v plus b into v. So let us call this as a equation number 2. This is our first equation. This is my first equation. I hope this part of your is cleared. Now I am erasing this part so that we obtain the solution of this equation, right? Okay. Now let us put v equal to 0 in equation 2. If we put v equal to 0 in equation 2, we get 1 equal to a, we get the value of a. Okay, now 1 plus v equal to, let us put the value of a in equation number 2, 1 plus 2v plus b into v. This one and this one will get cancelled. V into this minus 2v equal to b into v. V minus 2v minus v equal to b into v. V get cancelled and we get b equal to minus 1. That means this term 1 plus v divided by v into 1 plus 2v equal to, we can write this as 1 divided by v, and this as b is minus 1 divided by 1 plus 2v. Okay, so that the above equation, this dx divided by x plus dv divided by v minus 1 divided by 1 plus 2v into dv equal to 0. Now see the derivative of this term 1 plus 2v with respect to v, we get that is 2 into dv. So we need 2 here, so that we multiply and divide by 2. Then here integration gives, now integrate this directly. Integration of this is as log x plus integration of this is as log v minus 1 by 2 into log of 1 plus 2v equal to log of c. Okay, now apply the log rule. If we apply log rule, log a plus log b equal to log of a into b. Simple. Log a minus b a by b equal to log a minus log b. So therefore, for the first two we write this as log a into b, and this term will be in the division. Okay. So here you can see that this is a log of x into v divided by, we write this as a 1 plus 2v whole raised to 1 by 2 equal to log c. Log get cancel, and when we get log get cancel, we get x into v divided by 1 plus 2v raised to 1 by 2 equal to c, right. Now let us put the value of y. X into y divided by x divided by 1 plus 2 into y by x whole raised to 1 by 2 equal to c. This x get cancel. Now here we can take reciprocal, so that this will be root x in the denominator, and we write it in the numerator, y into root x divided by x plus 2y whole raised to 1 by 2 equal to c. Now this is the solution of this differential equation. So friend, you have seen how we can obtain the solution of homogeneous equation. We have seen two simple examples of homogeneous equation. Now we proceed for non-homogeneous equation. In the homogeneous equation, very important thing is that the degree of each equation is each term is the same. The coefficient of dx and coefficient of dy, or in the dy by dx, when it is of the type f1 of x comma y divided by f2 of x comma y, the degree of each term is same. You have to just look at the degrees. Whenever degree is the same, without thinking we have to put y equal to vx. But remember that whenever you know how to differentiate, how to find the integration, so then you can easily become a master of differential equations. The thing is to do, you have a list of formulas of integration, list of formulas of derivative. Without confusion, you can easily apply that. Otherwise, what happen if you don't know how to calculate derivatives or how to calculate the integrations, then you will have problem in treating these differential equations. So to become a master of differential equation, the very first thing is to have to practice the integrations, and very simple integration. We do not need much complicated integrations. You can see that there are very simple integrations arrive in the differential equation to get the primitives. Primitives means relation between x and y. So therefore, whenever you become a master, or for a mastery, you need to integrations and derivatives. Now let us see the non-homogeneous equations. Now we proceed for non-homogeneous equations. Just like differential homogeneous equation, here different these are the differential equations with a different degree. Dy by dx equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. These are the constant terms, okay. See, and you can see that here is a no variable, and therefore we have a 0 degree, okay. Degree of each term is a different here. So these type of equations are called as a non-homogeneous equations. To solve these equations, we call it as equation number 1. To solve these equations, we have to put here x equal to x dash plus h and y equal to y dash plus k, where h and k are constants. Now then here dx equal to dx dash and dy equal to dy dash. Let us put this value. Now we get new variables we are substituting. So we have to write here dy dash and here dx dash. Now a into x plus h plus b into y plus k y x dash plus h and y dash plus k plus c divided by a dash into x dash plus h plus b dash into y dash plus k plus c dash. Now let us solve this. This is equal to ax dash plus by dash plus ah plus bk plus c constant terms divided by a dash x dash plus b dash y dash plus a dash h plus b dash k plus c dash. Now whenever in this expression if these constants ah plus bk plus c equal to 0 and a dash h plus b dash k plus c dash equal to 0, whenever this is equal to 0 we get dy dash divided by dx dash equal to ax dash plus by dash divided by a dash x dash plus b dash y dash. Now look at this equation friends. Here we do not have a constant terms and degree of each differential equation is same. So we arrive at a homogeneous equations. This is a homogeneous equations and we can apply the method of homogeneous equation to solve these equations. Now friend, this method fails whenever we have a divided by b equal to a dash divided by b dash. Whenever this ratio is the same, this method fails, or in this we have to put here a divided by a dash equal to b divided by b dash equal to 1 divided by m. Whenever this ratio is the same, then this equation equation number 1 here equation number 1 will be dy divided by dx equal to ax plus by plus c divided by here a dash equal to m into ax plus by plus c dash, whenever this ratio is equal, so that we get a dash equal to a into m, b dash equal to b into m, and we can put this value here and we get m common term and we write this as a ax plus by plus c dash. We get this equation, and in this equation we have to put here v equal to ax plus by. Whenever we put this term v equal to ax plus by, then this equation then variable will be separated. Okay, so what is the method of solution of to find the solution of non-homogeneous equation? Non-homogeneous equations you can see on your screen, that is ax plus by plus c divided by a dash x plus b dash y plus c dash. So first kind you have to put x equal to x dash plus h, y equal to y dash plus k, and to find the constant h and k we have to put we have to solve these two equations, ah plus bk plus c equal to 0, a dash h plus b dash k plus c dash equal to 0. Whenever we solve this equation we get easily the value of h and k. Now next, when this method fails, whenever a divided by b equal to a dash divided by b dash. Whenever the method fails, we have to put this term a divided by a dash equal to b divided by b dash equal to 1 divided by m, and whenever this ratio becomes constant, then in this ratio, in this method, whenever the ratio is equal, this we cannot apply this method, and we have to put here v equal to ax plus by. Then you can see that whenever we put v equal to ax plus by, we get dv by dx equal to a plus b into dy by dx. A plus by equal to dy by dx, and then the equation will be easily reducible. So let us see examples of non-homogeneous equations. I will write here example. I hope you have get this idea. What we have to do here, dy by dx, this is my dy by dx, and this is a non-homogeneous equation. In this equation you have to put here x equal to x dash plus h, y equal to y dash plus k, and this values of h and k is obtained from this equation. We can solve this equation, these two equations, to find the values of h and k. To find the values of h and k, here these are the two equations. Here you can solve this equation to find the values. Now whenever this method is fail, whenever these ratios are equal, a divided by b equal to a dash divided by b dash, in this ratio the equation reducible to this type of equation. Okay, whenever equation reduced to this type, you have to just put v equal to ax plus b. Okay, then this equation will be reduced to a variable separable method. So let us see the example of non-homogeneous equation. I will write one example. 3y minus 7x plus 7 into dx plus 7y minus 3x plus 3 into dy equal to 0. So friend, here you can see that if this is a ax plus by, here a equal to minus 7, b equal to 3, c equal to 7. Now you can see that here a dash equal to minus 3, b dash equal to 7, and c dash equal to 3. If we check a divided by b, a divided by b minus 7 divided by 3, a dash divided by b dash, a dash divided by b dash minus 3 divided by 7. So ratios are not equal. Then we can apply our first method, first criteria. Let us put here x equal to x dash plus h and y equal to y dash plus k. Let us put now here 3 into y dash plus k minus 7 into x dash plus h plus 7 into, now we have dx dash, plus 7 into y dash plus k minus 3 into x dash plus h plus 3 into dy dash equal to 0. Okay, here 3y dash minus 7x dash plus 3k minus 7h plus 7 into dx plus 7y dash minus 3x dash plus 7k minus 3h plus 3 into dy dash equal to 0, right? Here dx dash. Now we choose this h and k so that this 3k minus 7h plus 7 equal to 0 and 7k minus 3h plus 3 equal to 0. So let us multiply this equation by 3 and this equation by 7. Okay, if we multiply we get 9k minus 21h plus 21 equal to 0. Here 49k minus 21h plus 21 equal to 0. So let us change sign, subtracting minus plus minus, and you can see that HH will be cancelled and HH will be cancelled, will gives us 40 minus 40k equal to 0 and this will gives us k equal to 0. So whenever we have k equal to 0, let us put this k equal to 0 in any one of the equation. Then minus 7h plus 7 equal to 0, minus 7h equal to minus 7 and h equal to 1. So we get the value, here I am writing the value of h and k. Let me erase this so that we will get a space. Now you can see that we have constant values. What is constant? H equal to 1 and k equal to 0. Okay, so we have these two equations. After solving we get these values. Now let us put these values now in this equation and let us solve these equations. Okay, so here we have taken these values, these two equation as a 0, this part is 0, this part is 0, then this equation becomes you can see this equation will be here, we get this equation, this much part, this will be 0 now, this is 0, this is 0. Okay, so let us write this part. What is this part? 3y dash minus 7x dash into dx dash plus 7y dash minus 3x dash into dy dash equal to 0. Now friend, we have a homogeneous equation and therefore let us put y dash equal to v into x dash, so that dy dash equal to v into dx dash plus x dash into dv. Let us put this value in this equation. Now substitution gives 3y dash, 3y dash means vx dash minus 7x dash into dx dash plus 7y dash means vx dash minus 3x dash into v dx dash plus x dash dv equal to 0. Now x dash common, x dash into 3v minus 7 into dx dash plus x dash common 7v minus 3 into v into dx dash plus x dash into dv equal to 0. So here you can see that we can take x dash as a common term again and cancel. So we remain with my 3v minus 7 into dx dash plus again let us multiply 7v minus 3 v into dx dash plus 7v minus 3 x dash into dv equal to 0. Let us write dx dash 3v minus 7 again plus 7v square minus 3v into dx dash plus 7v minus 3 into x dash into dv equal to 0. So here 3v this will be cancelled and we get this term as 7v square minus 7 into dx dash plus 7v minus 3 x dash into dv equal to 0. Now separating the variables, we can see that dx dash divided by x dash plus 7v minus 3 divided by 7v square minus 7 into dv equal to 0. Now adjust 7 common and we get v square minus 1. V square minus 1 means v plus 1 and v minus 1. V plus 1 and v minus 1. So that we write this 7v minus 3 divided by v minus 1 v plus 1 equal to a divided by v minus 1 plus b divided by v plus 1 equal to a into v plus 1 plus b into v minus 1 divided by v minus 1 into v plus 1. Okay. Now again we delete this. So what is the equation now? We have 7v minus 3 equal to a into v plus 1 plus b into v minus 1. So let us put v equal to 1. If we put v equal to 1, 7 minus 3 4 equal to v equal to 1 2a and this implies a equal to 2. If we put v equal to minus 1, v equal to minus 1, minus 7 minus 3, that will be minus 10. Minus 10 equal to minus 2b and this gives b equal to 5. So this term will be, this is equal to now dx dash divided by x dash plus 1 divided by 7 into 1 divided by 2 divided by v minus 1 and plus 5 divided by v plus 1 into dv equal to 0. Now friend, we arrive at a very simple integration. Let us integrate this. If we integrate this, we get integration. Look at this integration. You can see that integration of this is as a log of x dash plus 1 by 7 into integration of this 2 into log of v minus 1 plus 5 into log of v plus 1. Okay, so this is equal to log of c. So let us solve this. Let us solve this as a log of x dash plus log of v minus 1 2 by 7 and v plus 1 5 by 7 equal to log of C, or log of x dash into v minus 1 raised to 2 by 7 v plus 1 raised to 5 by 7 equal to log of C, or x dash into v minus 1 raised to 2 by 7 v plus 1 raised to 5 by 7 equal to C, right. Now let us put the value of v. What is the value of v? Y dash divided by x dash, y dash divided by x dash. So this is equal to y dash divided by x dash. Let me write this: x dash into y dash divided by x dash minus 1 raised to 2 by 7, y dash divided by x dash plus 1 raised to 5 by 7 equal to C. Okay, what is x dash? X dash equal to x plus h, x plus 1, and y dash equal to y plus k, y, x equal to x dash plus h. So x dash equal to, here we have to write here x minus 1, and y dash equal to y. So we write this as a x minus 1 into y divided by x minus 1 minus 1 raised to 2 by 7 y divided by x minus 1 plus 1 raised to 5 by 7 and equal to C. This is the relation. Now also we can simplify this relation again, and so that, or we can take it as a raised to 7. If we write it as a raised to 7, this will be x minus 1 whole raised to 7, so that y divided by x minus 1 minus 1 raised whole square into y divided by x minus 1 plus 1 whole raised to 5 equal to C1. C1 means C raised to 7, right? If we take the reciprocal of this, we can take reciprocal of this. Then let me solve this again. Let us take the reciprocal in the term. So this will be x minus 1 whole raised to 7, y minus x plus 1 divided by x minus 1 whole square into y plus x minus 1 here whole square whole raised to 5 divided by x minus 1 whole raised to 5 equal to C1. Now x minus 1 whole square and x minus 1 whole raised to 5, this and this will be cancelled, and we arrive at y minus x plus 1 whole square into y plus x minus 1 whole raised to 5 equal to C1. This is the solution of non-homogeneous equation. Okay friends, I hope you have get the idea of homogeneous equation, non-homogeneous equations, and solution of homogeneous and non-homogeneous equations. Thank you friend. Remember that practice made man perfect, and in mathematics we have to do a lot of practice to become a master of this. Thank you for watching and being with me.